Welcome to this video lesson on goodness of fit. After completing this, you will be able to evaluate if a linear regression fit is good or bad. Define goodness of fit and interpret R-squared values. Let's consider the linear regression equation shown on the screen. The purpose of this equation, or regression line, is to predict the y values from the x values. You can see that all the points are on the line. Thus, x can accurately predict the y values. But, what if x values are not able to forecast the y values? In the example shown on the screen, the points are not falling on the line. And there is difference between the predicted y value from the linear regression equation and the observed y value. Goodness of fit tests how good the regression line is in predicting the actual y values. The fitted line is considered to be good if the difference between the predicted and observed value, or error, is very low. And at the same time the error should be random. Here you can see that the error increases by 1 unit for each observation. If the error is not random, then you can predict one error from another. In other words, your linear regression model is not good. A plot of error is called residual plot. The screen shows the residual plot. Can you tell us if the regression fit is good? You can see some patterns in the error. Thus, this linear regression model is not good. After some improvements, the residual plot looks as shown on the screen. Do you think the regression fit has improved? Yes, the errors are now random, and this is a better model. The next step is to assess the goodness of fit through some numeric measures such as R-squared. R-squared evaluates the difference between the predicted and observed value. R-squared is the percentage of the dependent variable variation that a linear model explains. The calculations are covered in detail in the next notebook. What is a good value of R-squared? R-squared value ranges between 0 and 100%. A higher R-squared values represent smaller differences between the observed value and predicted values. A R-squared value of 0% means the linear regression line cannot predict the y values. On the other end, a R-squared value of 100% means that x can accurately predict the y values. How do the scatter plots look for different values of R-squared? The scatter plot shows the R-squared of 15%. As the R-squared value keeps increasing, the data points keep coming closer to the regression line. At 100% all data points are on the regression line. However, this does not occur in real-world situations. Is low R-square always bad? Generally it is bad. The R-squared for this graph is 49%. But you can see that as x increases, y tends to increase too. You can see that there is still some information, which can be extracted from the model. Is high R-squared always good? The R-squared for this graph is 99%. But none of the predictions are point accurate. Such models would be useful in forecasting the direction of the price. Let's review what we have learned in this video.